BGP path is determined not based on simple metric like bandwidth or delay or hop count, but based on policy. That's the main reason why we choose BGP as a routing protocol. We can tell BGP what path we want to reach so and so destination. To write the policy, we use those flexible but more effective metric called attributes. With the help of attributes, it is easy to convey to BGP what policy is there in our mind in selecting a path to reach some destination. The type of attributes we need to understand. When we understand the attributes and what they do, we will be able to use the right attributes to configure to achieve what we want. To understand that, we have here the attributes are classified and categorized under 4 different groups: well-known and mandatory. That's one type of attribute. Well-known, discretionary, optional, mandatory, optional, transitive. That's equal to actually mandatory. Optional, non-transitive is equal to mandatory. Optional, transitive is equal to discretionary, but not exactly equal. It's different. We'll try to understand these differences in much detail in coming slides. So, when the optional attributes are configured, it is complete. If it is not, then it is partial. So, when do we call it as partial? The updates are partial when optional attribute is not present. Yeah, it is optional, but if it is present, then it is complete. If not, it is partial. The other meanings we all understand. What well-known means, what well-known discretionary means, mandate means. The attribute that must be there in every update is well-known mandatory. The attribute that is popular but need not to be there present in every update may be present. They are well-known discretionary. So, mandate, discretionary. Mandate should be there. Discretionary may be present. Though it is discretionary, but still it is a well-known one. Well-known, discretionary. Optional attributes, every BGP running devices will have this optional, but in that we have two different categories: optional transitive, optional non-transitive. Though it is optional, some vendors will say we want it. If not, we will not use it. We will discard it. Then it is called as optional non-transitive. Optional non-transitive. Though it is an optional one, this particular product vendor says, no, we want to see it. We want to use it. We want every BGP updates to come with that attribute. That's what called as optional non-transitive. Optional transitive is equal to optional. If not recognized, it is marked as partial and used, propagated. Few attributes are listed here. There are more which will be coming later. And why only few listed here? These are the attributes that we often use to manipulate, use to tune the path. This is not in a order. This is just to introduce us the topic, different attributes, and under what category it comes. The first one is AS path. But this is not the first in the attribute list. Here in this page it is first. Attribute list will come later. AS path is the well-known mandatory attribute. See the one with the star written at the bottom saying well-known mandatory attribute. What does that mean? When a network is advertised, along with the network, the subnet mask and the autonomous system that advertises this network, the autonomous system in the path that distributes the network, all those autonomous system info also get attached in the advertisement. So when you capture an advertisement, when you capture the advertisement, and if you can see the advertisement, yes. Next hop is also mandatory and popular, well known. Without these attributes, updates are considered as void. They're not updates. They're not valid updates. Updates should have all that is marked as well-known mandate. Whether it is from Cisco device or from Juniper device or HP device or Huawei device, it should be seen along with the network. These informations are also carried. That's why BGP updates are big. Okay, the next hop is nothing but the address of the eBGP neighbor. Origin describes how this network is introduced into BGP. See, we can introduce a network in two different ways. One, by advertising using network command. The other one by redistribution. We can take from some other source like OSPF and redistribute it into BGP. So we have origin to describe how the network is introduced. When you see that small marking like I or question mark, you'll be able to describe it. If you see I in the BGP's update, it means network command is used to advertise. Instead, if I have a question mark, then it is redistributed into BGP from some other source. That's talking about origin. Well-known mandate. Local preference. This is also a well-known one, but not a mandate one. Local preference is a numerical value that shows the preference level inside an autonomous system. What direction the traffic should flow to exit out of the autonomous system is defined using local preference. It is called as local preference because it is local to all the routers within the autonomous system. This weightage matters, not to the eBGP neighbor, to all IBGP neighbor. To inform every IBGP routers inside the autonomous system about the exit point, local preference is used. Exit point. Traffic going outbound. MAD, multi-exit discriminator. This is opposite. This is inbound traffic. If a traffic can enter in via left and right, you are going to say using MAD via which it has to enter, left or right. You might have seen in some countries, in some buses, they'll put a women's symbol in the front, gent symbol in the back entrance of the bus. So that shows that men are not allowed to enter through the front door of the bus. Same way, inside, while moving inside, there is a boundary inside, like I've seen in some countries. I'm not sure about India, how much you can go deep inside the bus. From back to the middle, gents can go. Likewise, front to the middle, women's can go. Exit is also the same place where they enter. So that shows the preference for whom this entrance and exit is. Many metros have got that pink color box only for women's. Again, I'm not sure about India. Local preference is to say how the traffic should exit in order to reach that destination, how it needs to exit from this autonomous system to reach the destination, whereas MED is to tell how the traffic should enter in order to reach the local destination within our autonomous system. But multi-exit discriminator MED is not a mandate one, and it is not used in all scenarios. It can be used only when you have dual homing scenario. This describes the AS path. If you notice here, 192.168.1.0 network, which is here, when it is learned here, it learns the network with these two autonomous system number. The autonomous system sequence. So when this advertises, it also includes this info and advertises it. When this advertises the network, it also includes this one with this one. That's how you got the AS path sequence. Next is the next up attributes. As you all know, we all know that eBGP address is carried into iBGP. So when router C receives, the next stop is going to be 10.10.10.3 when C receives it. So the next stop address is always the address of the next autonomous system. It is not the next router. The reason is BGP is autonomous system by autonomous system routing protocol. It's not hop by hop, rather it is autonomous system by autonomous system routing protocol. And this is also a well-known mandatory. As I said, origin describes how the network is introduced. When we use the network command to advertise, it is I. When you use the old protocol called EGP to advertise, then it is E. We don't have EGP in our today's routers. Maybe if you will have some old routers, like 25 years more older routers, you may find the EGP. And then question mark is when we redistribute from some other protocol like OSPF or ISIS or a static route into BGP, we get question mark. Again, this is also well-known mandatory. So this is the I that I was talking about. This shows that these networks are advertised using network command, not redistributed. What is the difference between this I and this I? This I is talking about I have learned this network from local IBGP neighbor. This is IBGP neighbor learned route. This is origin code. This is different. That is different. This I is internal IBGP learned route, whereas this I is IGP, meaning internal to the protocol. This is not IGP protocol. This is IGP here. Means BGP's own internal network, not someone's network. So the I that you see at the last is the origin. This I is not origin. This I tells that I am learning this from IBGP neighbor. When you don't have I, which means I'm learning from EBGP neighbor. Local preference is well known, but not a mandatory one. It cannot be, because between the EBGP, we don't advertise this. This attribute is advertised only to IBGP neighbor. So though it is well known, it is only discretionary. Now whether you configure this local preference or not, there will be a default local preference 100 on all the routers. But if you will configure something bigger than 100 on one of the router, then that router will be the exit. In this example here, all the routers that belong to 64520 autonomous system will exit via router A in order to reach 172.16.0.0. The reason is 200 is set. On router A, 200 is set. And when you don't set, it is 100. When you set, it is 200. Sorry, it is set as 200. It is also set as 150 on the other router. Now, if RA is not up, If router A goes down, then automatically traffic will exit via B, because this has got next highest local preference. Now this local preference you no need to configure on every router. When we configure on one router, it gets spreaded to all the routers within that autonomous system. But this won't be spreaded across, only within. It won't be sent to another autonomous system. MAD is an optional non-transitive. What is optional non-transitive? It should be there. Even though it is optional for Cisco, MAD should be there. At least 0. Yeah, the default is 0. If MAD is not seen in the updates, Cisco routers won't use the update. Even if it is 0, it should be there. MAD actually lower is preferred. MAD is same like metric, smaller is preferred. So what do we understand in this picture? Autonomous system 65500 will receive traffic like this, because 150 lower is preferred. For this autonomous system, inbound, you have defined inbound. What should be the inbound? What should be the ingress router? It's B. By setting 150, we have made B as the inbound, ingress. We want traffic to enter via B, not via C. C should be used as a backup. Weight is an attribute which we see in every vendor, but in a different name. Here, Cisco says weight. And also they have written Cisco only. I do agree, Cisco only calls it as weight, whereas others calls with a different name like preference, not local preference, simply preference. Juniper calls it as preference, Huawei calls it as preference. Now, this is also same like local preference helps to decide the exit, but the difference is this is local to the router, that is to the entire autonomous system. So when I configure weight on one router, only for that router to take a decision, that weight is configured. Whereas local preference, when I configure on one router, every router will know that I have configured on this router. So if you want one particular router to take a different path, then you can go with weight. If you want all the router in your autonomous system to take one path, then you need to go with local preference. Right, so what we have seen is about these attributes, what they do, and under what category they are kept, like AS path, next stop, and origin are well-known mandatory. So attributes in BGP are very important to understand. There's nothing other than attribute in BGP. So if we don't know attribute, we cannot say we know BGP. That's why we spend more time here. Now, as I said earlier, BGP is not going to decide a path based on bandwidth. It is only based on the attribute. Using attribute, you define the policy. That is the reason why we go for BGP. We do not want a protocol to decide a path. We want a requirement. We have a requirement. We want a path as per the requirement. So we need a protocol that will understand our requirement. That's why we choose this protocol. Mostly the policies comes between autonomous systems. Within autonomous system, we don't have much policy. There are some small requirements, but that can be managed using simple protocol like OSPF. But the policy that we need when you go and work with ISP network, you will understand the big picture of BGP. Oh, there will be thousands of routes, and few hundreds you want to go via X, few hundred you want to go via Y, few hundred you want to go via Z. You have various policy requirements. To achieve, we need this BGP attribute. A simple protocol can't do this. OSPF or ISIs cannot do this easy like what BGP can do. Using BGP, you can easily achieve that. Now, one thing to remind is, though BGP is a protocol with all those attributes, end of the day, the decision maker is not BGP. The final decision maker is the routing table manager. See, routes are given to the routing table manager by OSPF, by BGP, and by other protocol. Now, based on the administrative distance, routing table manager will decide whether to consider the BGP given route or OSPF given route. If OSPF and IBGP provides route for the same destination, then OSPF is going to be preferred. As you already know, administrative distance is lower for OSPF. Right, next. The route from the source with the lower administrative distance is installed in the routing table. That's the reason why sometimes BGP routes won't be seen. Administrative distance matters. IBGP is 200 in Cisco. OSPF is only 110. So OSPF is preferred. Now, this is the sequence in which attributes are checked. When an update comes, it comes with attributes. Likewise, when a packet goes out, this is the sequence in which it is going to check. Do I have a valid next hop? Yes. How many valid next hop? More than one. Okay, then goes to the first one. If I have more than one valid next hop, do I have any weightage for one of the next hop? Yes. Then go via that direction. If no weightage is set, then is there any local preference set? If yes, go via that direction of the router which has got high local preference. The default weight is 0. Default local preference is 100. Higher is preferred. Now, when there is tie in this two, comes the origin. This origin is different from attribute 5. Attribute 5 is origin code. This is origin. Prefers route originated by local router. Prefers route originated by local router. Meaning, if you will have a next hop 0.0.0.0, which means that network is locally advertised. If someone else advertises the same network to you, you don't need to go to that network, that destination when you have locally on this route. Now, if this is not a tiebreaker, then goes to the next one. Do you have a multiple path with different AS path length? If yes, then choose the path with the shortest AS path. If both the paths have got same number of hops, then choose the path with a lower origin code. I is lower than E and E is lower than question mark. Prefers lowest origin code. Now what if both the paths are having same AS length, AS path length, same origin code like I? Then it will see whether I'm learning through dual homing. Two neighbors connected back to back via two paths, two neighbor adjacency. Back to back on the same router like this. This is one adjacency, this is another adjacency. Dual homing. This is in one autonomous system, this is another autonomous system. Only then the MED will come into picture. This can be on another router also, but from the same autonomous system. This is dual homing. Then what is multi-homing? Multi-homing is this is one autonomous system, this is another autonomous system. That's multi-homing. Now, when you have dual homing, lowest MED value matters. We saw that as an example here. This is dual homing. A is connected to 65500 via two adjacency, B and C. If there is no dual homing, then from 5 it jumps to 7. Is one of your neighbor EBGP? Then go via that neighbor. Now, both are IBGP. Then what should I do? I don't have one EBGP and one IBGP. I have both EBGP or both IBGP. If both are IBGP, which IBGP is closest? IBGP, how do you know whether it is closest or far away? By the local IGP protocol like OSPF metric. OSPF metric to reach that IBGP and this IBGP. Which IBGP has got lowest? Prefers the path through the closest IGP neighbor. Next, what if I don't have IBGP, I have both EBGP? Then see which EBGP gave you the route in the beginning, earliest, oldest. Go through that EBGP which gave you first. There won't be a tie after this in case if there is a tie. Then choose the neighbor whose router ID is lower. Even if there is a tie in this, there is no chance actually if in case. lowest neighbor IP address. Right. So this sequence is what routers count while deciding the forwarding plane. Right. So what is next is we need to apply these things and see in a lab using a route map. We write the policy, we set the local preference, wait or MED or origin or AS prepend and so on. Then we'll do a one big full lab to check all these things, and then we will get into another topic.